We have trigonometric identities. This is NCV level 4. We're given question 2.1 says solve for x in the interval from 0 degrees to 180 degrees if sine 2x is equal to cos 3x multiplied by cos x plus sine 3x times sine x, right? That is what we're given. We're given the sine 2x is equal to cos 3x multiplied by cos x plus sine 3x multiplied by sine x, right? So they should solve for x, right? We want x there. Should solve for x. Here we'll have sine 2x on this side, but if you check here, we have 3x, we have 3x. As you can check, you have x, you have x. This is what is a compound angle of cos, right? So we know that the compound angle of cos will be cos, right, 3x. But now here there is a plus. Remember, we'll change when comes to side, will be as negative. Interchange the sign there. Then that will have sine 2x. Then this is cos. When you subtract 3x minus x, it simply equals to what? 2x. Then you can divide both sides by cos 2x. This and this will cancel, and then we'll have this side tan 2x will be equals to 1. Then 2x will be tan, then 2x will be equals to press shift tan 1, have 45 degrees, right? This is our ref angle. Then we know on our Cartesian plane here it is theta, which is also tan is positive, where on the third quadrant weight by is 180 plus theta, right? We'd use that from a case diagram. So we'll have 2x is equals to, from first quadrant, we'll simply take that 45 degrees divide by 2. X will be equals to what? 45 divided by 2 is 22.5 degrees. So what about quadrant 2? We know that will be, we'll have 2x is equals to 180 degrees plus 45 degrees, right? Then here we have 2x is equals to 180 plus 45, which is 225 divided by 2. Then our x there will be 112.5. That is the value of x, right? We have that. So here 2.2 are given to simplify this. They were given to simplify sine x multiplied by cos 30 degrees minus x plus the cos x sine 30 minus x all over cos x multiplied by cos 45 degrees minus x minus what? Sine x multiplied by sine 45 minus x. This is what we are given there. So I can rewrite this. We have to do what here? Question 2, to simplify the expression without using a calculator. So let me write accuracy. they were given sine x multiplied by cos 30 minus x multiplied by cos what? Cos x multiplied by sine 30 minus x. This is what we have over cos x multiplied by cos 45 minus sine x sine 45 minus x. This is what we have, right? So we should simplify this. Okay, let me add the page. Sorry about this. Can I add some page here? Okay, right. Sorry about this. Okay, now we have some pages here, right? So if you can check, we have sine here, right? There is no minus something here. This would be plus or something. Okay, we have plus here. This plus, you see, you have x, we have this, then we have that. As you can see, this is a compound angle of sine, right? So on our numerator of the compound of sine, but let's check on our denominator of cos. Yeah, sine, the angle are the same. We have compound angle of cos, right? So here you simply have equals to, there on the top will have sine into x, right? We have this is plus, right? That one, this one affect, because plus when you multiply it will be 30 minus x. Supposed to put a bracket like this, but because there is plus, it does not affect in a way even if we multiply them. But be careful, we'll always put plus parentheses, put parentheses. Then this will be over this compound angle of what? Of cos. Simply have cos first angle there, it's what? It's x. Now remember, when it's, do not forget, when it's cos, this will change and becomes what? Plus. There we have 45 minus x, right? This is what we have there, right? So this and that will cancel. If you know your maths, this and that will cancel. You simply have sine 30 over cos 45 degrees. This is our special angles. Right there we have sine 30, which is the special angle. Simply 1 over 2 here. We have cos 45 simply equals to the square root of 2 over 2. Remember, there is this diagram here. You can see 60, 30. There, when you have 30, we will have 1. There, this is square root of 3. You want to see? So, adjacent. Remember, cosine is opposite. It's opposite over adjacent, right? Yeah, this triangle there, you must use this special angle triangle either way. Even if you press on the calculator, they won't see. But now, when you hear, you simplify your math. This is 1 over 2, right? So this is the same. When you, this is a division. When you divide, you will change this division by what? By multiplication. We've changed that to be multiplication. But now, after changing that, you interchange the values. What? 2 will comes on the top, then the square root of Also the square root of 2 will comes at the bottom interchange, right? Then you see this will simply cancel. We'll have 1 over root 2, whereby this you can say 1 over root 2 multiplied by root 2 over root 2. This will be equals to root 2 over 2. Yeah, this is what we have so far. All right, 2.3, prove the following identity. We should prove the following identity. We are given that tan, right, 2x plus 1 over cos 2x must be equals to sin x plus cos x all over cos x minus sin x. Right, this is what we are given there. Right, we have this. We should prove. I will choose the left hand side. You can choose the right hand side if you want, but let me choose the left hand side. I have tan 2x plus 1 over cos 2x, right? So I should prove this there. So I'll simply change this. It's the same as sine 2x over what? Cos 2x. We know that. There we have 1 over cos 2x, right? Isn't it? So here our denominator is the same, right? So we'll add what is in the numerator. It will be sine 2x plus 1 over cos 2x. This is what we have. Then we check on the right hand side. We must stick to the right hand side either way. As we simplify, we see here we have sine plus cos x. We must stick to the right hand side, so we don't have 1. As you can see on our numerator, what we want to prove, we want to prove this, guys. Let me grab. We want to prove this, isn't it? As you check here, let me highlight. As you can check here, we don't have, as you can check, there is no 1 there. There is no 1. So there is no 1. We have that. Since there is no 1, here we have 1. We must eliminate this 1. We must try to eliminate that 1. So how can we eliminate this 1? There is no way. Simply we have to change that 1. We can change this either way, because here we don't have what? We only have x's. So let's change, and then we have cos also. Then we can change. How can we have cos on the numerator and sine? We check. Let's change here, because if we change this, will be 2 sin x multiplied by cos x, right? But 1 is the same as sine squared x plus cos squared x, isn't it there? This one, you see what we have here. We have cos minus x, but here we have what? Cos 2x. Let us change that. We want to have sine, but here we have cos only. So we can change. This is a double angle. We can change to sine squared x minus sine cos squared x minus sine squared x. Now we have sine, we have cos, we have cos, we have sine. So we're on the right track, as you can see. And now there on a, if you can check, you must be carefully rewrite these. We have cos, so you can check. We have cos here. I will rewrite cos here on the top, cos squared x, because here we have cos. Then this will be simply plus 2 sine x multiplied by cos x plus sine squared x all over. This is the difference of two squares. As you can see, this will be simply equals to cos, because here check, we have, there is no squared. We must remove this squared. How can you remove it? Check your right hand side, guys. How can you remove that squared? We have no other chance. Here we have squares and we have minuses. I don't want these squares, because here what we want to prove, there is no squares there. So I will simply, this will be difference of two squares. Now we're on the right track. Now we are on the right track. Right now we are on the right track, but this one on the top, suppose we know this one on the top, that will be simply equals to cos, factorize what is in the top there. As you can see, you can factorize that. You remember, if you have something like that, is this thing of this form, x plus y squared. Do you still remember that? What on the top, so is this format that we have there. So we have it in terms of what? We have it in terms of sine, but we have this there, cos x plus sine x. This is what we have actually on top, in the form of what? Of that. So this is simply equals to sine, if we factorize that, plus sine x bracket like this, sine x plus cos x. So we're on the right track. We have plus, we have this. Now we're on the right track. We divide by what we have, the difference of two squares. Here we have our difference of two squares, cos x minus sine x, into sine x plus cos x, but this will cancel. No, this is minus, but this will cancel with one of that. Then we'll be left with, there will be left with cos x plus sine x all over cos x plus sine x. So this is it, guys. We have proven, therefore left hand side is equals to the right hand side. As you can see, this is what we have. We're supposed to prove this. Now the left hand side is equals to the right hand side. As you can check, our right hand side, this is the one and the same thing. So we are done, guys. This is what we have there. This is one and the same thing. Now what do we have also? What left? Okay, we're done with this question. Thank you guys for your time. Please guys, support me, please. For the sake of support, please do not forget to subscribe. Right, do not forget to subscribe to my YouTube channel, right? So you'll help me to grow this channel and help me. When you subscribe, you give me energy to post more videos. You can like, guys, and comment. Thank you, guys.